Hello, I'm going to go over the problems right now. So for problem number 1, we're using product and exponent notation. Product notation means that we want to rewrite repeated addition with a coefficient, and for exponent notation, we want to rewrite repeated multiplication with an exponent. So one thing that you should do always is to group together terms that are multiplied together. So notice everything is multiplied together here, so I can put parentheses around there. However, for this next one, notice that these 3 terms are multiplied together, but these other 2 are not. So these 2 are also going to serve by themselves. Okay, oops. So these are going to be by themselves. I'll do that for this problem as well, and for this problem as well. Okay, so now I can write repeated addition as a coefficient and repeated multiplication as an exponent. So here I see 2 a's, so I know that it's going to be a squared. I see a b, there's going to be a b there. Notice that there's no multiplication signs. That's also part of product and exponent notation. And then also there's this 7 and this 3 I need to multiply together to get 21. Okay, for problem number 2, there's 3 b's together like that. So b cubed, and then there's b plus b, but I can rewrite that as, because there's repeated multiplication, b cubed plus 2b. Okay, for part C, I have 2d cubed minus 3d squared, and then finally I have 2a squared minus 3, and then we're just going to keep whatever's in the parentheses in those parentheses. So these terms right here, we'll just make sure that we combine the 2 b's. So 2b minus a. Okay. Problem number 2 asks us to just write it in expanded form. Of course, I think there's a number of ways you can do this. The back of your book probably gives you one answer. All I want you to do is write out exponents as repeated multiplication. So for part A, because there's t to the 4th, I'm going to write down 4 t's. Okay, that's for part A. For part B, I'm going to write everything that's in the parentheses out. So if there's 3b cubed, then that means that the 3b must be multiplied 3 times. Then finally have 2 times b minus 3 times c times c times c. Okay. Write out it in words. I'm just going to give you a few of these. You can look over your answers in the back of the book to see what other ways you can represent it as. I'm going to say m over 3. I'm going to say 3 times x. I'm going to put all squared to indicate that the 3 is also part of that squared. And c, I'm going to say, is the sum of a and x squared. Notice I don't use all squared because the only thing that's being squared is that x. Number 4, write as an algebraic expression. Here I'm going to make sure that I know what these words mean. For instance, I see the word total. That means addition. 5 more means addition. Square root of x means square root. Sum means adding something. And there, we know that there's a square there as well. So part A, it's going to be a plus b plus c. For part B, it's going to be 5 plus the square root of x. Part C, it's going to be k plus something else, and the other thing I know that k is summed with must be the square of h squared. Okay, number 5. Gina bought an apple of 18, a bag of 18 apples. How many apples will be left in the bag if she eats? Okay, so I know that this must be a subtraction problem. That is, because I'm given some sort of total, and if she eats apples, they can only be going down, so that must mean subtraction. One thing I will note, though, is that I have an amount of apples per day, and I have the number of days. So to figure out how many apples she eats in total, I will multiply the apples per day by the day. So for part A, it's going to be 18 minus 2 times 3, which is the same thing as 18 minus 6, which is 12 apples remaining. For part B, I'm going to do the same thing. I'm just going to make sure that I go out of 18, so subtract whatever I'm going to subtract from 18, and then I'm going to multiply the apples per day by the amount of days. So minus A times 3, which is going to be 18 minus 3A. And then finally C, 18 minus A times D, which is going to be 18 minus AD. And all I've done is I've simplified that by making sure that there is no multiplication sign between the two letters. Let's go to the next problem. If P equals -2, Q equals 6, R equals -3, find the following. Remember, these problems just deal with substitution. You're going to replace that letter with its equivalent value, and just make sure you put parentheses so that you don't have to deal with tricky negatives. Okay, so r squared, instead of having r squared, I'm going to replace the r with -3 squared. Notice I put it in parentheses. That's going to equal 9. B is going to be P squared Q times R. That's going to be -2 squared 6 -3. So that's going to be 4 times 6 times -3. That's a -72. And for part C, it's going to be -2 minus -3. Okay, I should make sure I put these in parentheses. All over 2 times 6. So -2 plus 3 all over 12 is 1 over 12 is the final answer. Number 7. An object with a mass of m kilograms and acceleration of a has a force of ma newtons acting upon it. So just like this previous problem, I have an equation that I can use. It's kind of hard to find, but it's right here. It tells me that m is going to be equal to mass, and a is going to be equal to acceleration. So I should make sure that I keep track of those in the problem and work with them. Okay, so whatever mass is, whatever acceleration is, I just got to multiply them together. Okay, find the force acting on. Okay, so we start with a bicycle with a mass of 8 kilograms, acceleration of 9 meters per second squared. Notice here the mass I'm interested in is kilograms. I do have kilograms, so I can do a straight multiplication. So MA is going to equal 8 times 9 is equal to 72, and the units of force are going to be newtons. So 72 newtons. For part B, I just got to notice that the kilograms are instead grams. So whatever 54 is, I got to divide by 1,000 first. So 54 times 1,000 times 5 acceleration. That's going to be something like 270, I believe, 0.270. Give me 1 second. Yep, 0.27 newtons. Okay, now we get to number 8, number 9, and number 10. 8 and 9 are simply just knowing what the terms are. So for instance here, decide whether each of the following is an equation or an expression. An equation has an equal sign, expression does not. Okay, so part A is going to be an expression, part B is going to be an expression, and part C is going to be an equation, because that's the only one with an equal sign. Number 9, state the coefficient of P. So I want whatever term of P I see. It must be P with no power, notice, right? Or at the very least a power of 1. And I want to figure out the number in front of it. okay, as long as there's a number. Notice here that there is a p, there's no number in front of it, but we can always put in a number 1 in front of anything. And notice that the negative's also there, so this coefficient must be -1. For part B, even though there's multiple p's, the only one that's right there, that's on the numerator, not the bottom of a fraction, and the only one with a power of 1 must be that, and that has a coefficient of 7. Number 10, combining like terms. So to combine like terms, you take the terms that have the same variable to the same power, and you're going to add their coefficients. So 7 plus 6 is going to be 13k minus 6. Part B is going to be these two terms going together, and then 3 and -1 going together. That's going to be x plus 2. Part C, it's going to be 9f minus 8f, so it's the same thing as plus 8f. And 3g minus 8g, that's going to be 17f minus 5g. Okay, review set B, I'm going to go through really quickly just because it has the same sorts of problems as you saw on the previous review set. So this is going to be, the only two that go together are those, a plus a squared. I'm going to combine the a plus a, so 1a is going to be a squared plus 2a, or 2a plus a squared. Part B, I'm going to get 4p squared minus 6p squared q. For part 2, write as an algebraic expression q minus the square of p. It's going to be q minus the square of p, so p squared. Number 3, write a cubed minus 7a squared b cubed in expanded form. I'm going to do a times a times a minus 7 times a times a times b times b times b. Number 4, find the change from $20 when buying 3 ice creams at $2 each. So I want to figure out how much money I spent in total. There's 3 ice creams, they're $2 each. So I'm going to take my total amount, 20, and I'm going to subtract the amount that I paid. So 3 ice creams, $2 each. 20 minus 3 times 2. That's going to be $14 I have remaining. Okay. B, 3 ice creams at p dollars each. That's going to be 20 minus 3 times p, or 20 minus 3p. And finally, part C, that's going to be 20 minus c times p. Okay. Number 5, another substitution. Replace the letters that we're interested in. Part A squared times b, 3 squared times -1, that's a -9. Part B, that's going to be 3 minus 4. So I should put those in parentheses. Squared. It's going to be the same thing as 3 plus 4 squared, 7 squared, or 49. Okay. Part 6, 7, 8. 6 is another one where we have to plug in. N customers bought 2 muffins each, then a new batch of M muffins arrived. How many muffins does the stall now have? So a cake has 20 muffins. We want to figure out how many were sold. N customers bought 2 muffins each. So we need to remove the amount that they bought. That's going to be 2 muffins each per person, and there's N people. Then a new batch of M muffins arrived. So we add back on to the M. Okay. Number 7, coefficient of x. It's going to be this thing right here, 2. Constant. The constant, on the other hand, is just the number that goes by itself. It's going to be the 3 with the sign in front of it, -3. Number 8, simplify by collecting like terms. It must be these two terms going together. That's negative 5z plus 2. And these terms going together. U and U, T and T. That's going to equal negative 5t plus 12u. We have an x squared that goes by itself, nothing. We have two x's that go together. 3x squared minus 3x plus 5. Number 9. Consider the expression as below. How many terms does it contain? It contains 1, 2, 3, 4, 5 terms. So it includes 5 terms even if like terms are combined. State the coefficient of st. That's going to be this number right here, negative 10. C, state the term which is a constant. It's the number by itself, negative 2. If possible, simplify the expression by collecting like terms. Well, the only two like terms are going to be 7t and negative 9t. So we have 3s minus 2t minus 10st minus 2. Then we evaluate the expression if s equals 0, t equals 3. We're going to replace s with 3 and s with 0, t with 3. So I'm just going to use my answer right here to get 3 of 0 minus 2 times 3 minus 10 times 0 times 3 minus 2 is equal to 0 minus 6 minus 0 minus 2, or negative 8. Finally, we'll get to part 2 of part E. 3 times negative 1 minus 2 times negative 2 minus 10 times negative 1 times negative 2 minus 2. It's going to be negative 3 plus 4. 3 negatives, 1, 2, 3. It's going to result in a negative value. 20 minus 2. It's going to equal 1, negative 19, negative 21. Okay. We have a couple more. Sinbad went fishing. He cast his net out n times. It caught 6 fish each time. In addition, 3 flying fish jumped into the boat. Write an expression for the total number of fish in Sinbad's boat. Well, we start off with the fact that he catches 6 fish each time he casts his net. He casts his net n times. So we have an each or per style question. So that's going to be 6 times n, or 6n, plus the 3 fish that jumped onto his ship. How many fish did Sinbad return to shore with if he cast his net out twice? So here it's telling us that n is equal to 2, right? N is the number of times he throws it out. So n is equal to 2 for part I, and then part II, n is equal to 7. If n is equal to 2 here, we have 6 times 2 plus 3. That's going to be 15. If the n is 7 here, we have 6 times 7 plus 3. That's going to be 45. Okay. For part, and then finally, part C, suppose Sinbad cast his net out 7 times. When he returned to shore, he shared his haul with 4 brothers. How many fish did each brother get? So we have to check how many fish he catches when he casts it out 7 times. And did I do this wrong? No. Yeah. So we have 45 fish from part 2, and he shares it, I'm presuming here, with his 4 brothers as well as himself. So that's going to be 5 people total. Each person gets 9 fish. Simplify. So here we got to multiply it out. 3d times 3d. Right? Group the numbers together. Group the letters together. We get 9d squared. Okay. Here you have to make note that this thing is the same thing as -1 times x to the 4th. So here, it's going to be the same thing as -1 times x times x times x times x times 5 times x. I will get -5x to the 5th. Part C, I have x times y times -x times y. The negative will go all the way through, so that I get -x cubed y squared. Number 12, I will simplify, so I gotta write everything out. 15 x times x times x, 3 times x. Okay. I also have, for part B, 14 times a times b, 4 times a times b times b. I'll use my red pen now to mark off all the terms that are the same on top and bottom to eliminate them. And I'll also make sure I simplify the numbers. Here, 50 and 3 are both divisible by 3. I get 5 on top, I get 1 on bottom. 14 is divisible by 2, 4 divisible by 2. I get 7 on top, 2 on bottom. So my final answer, therefore, will be 5x squared on top, and then 1 on the bottom, which is the same thing as 5x squared. And then here, I have 7 on top, 2 on bottom, I have A, I have B. Okay. Number 13, and make sure that I just divide. Okay, so -4 over x. Divide means keep, change, flip. So I change it to a multiply, and then I flip the fraction. Okay. So if I multiply straight across, I get -12 2x squared. Part B, I just keep the same thing, a squared b times b over 3a. I get, I should probably rewrite this. A times a. If you want, you can just start canceling things right now. I know that this a and this a are going to cancel out, as well as this b and this b. Okay, so the only thing I have left is going to be a over 3. And then for part C, here, let's see if I can fit it. I have 2c times 2c on top. I have d on bottom. I have times 14d over c. I can start canceling if I want. C down here, d and a d, so this one will be a 1. And then what I have left is going to be 4 times 14, that's going to be 56. C over d, sorry, over 1, which is the same thing as 56c. Cool. Finally, part 14, find the highest common factor of 6y squared and 8y. I want to write those two out fully. So 6y squared is the same thing as 2 times 3 times y times y. 8y is 2 times 2 times 2 times y. So what they have in common is a single 2 and a single y. So the highest common factor is 2y. Part B, 10xy and 4x squared. 2 times 5 times x times y, and 2 times 2 times x times x. So what they have in common is the 2 and x, so 2x.